Tangents to y equals e to the x are drawn at p e to the p and q e to the q. These tangents cross the x-axis at a and b respectively. It follows that for all p and q, we have one of these relations. Okay. Well, I'm going to suggest we just draw a figure and try and figure out what's going on here. I suppose maybe the way to go, I know I've only drawn this for positive values of x, but I think hopefully that'll be sufficient for what we're trying to do. And I suppose what we'll do is, need something a little bit steeper. What I'll do is I'll just choose an arbitrary point. I'll call that p. And so this is, of course, e to the p. And I'm going to compute where the tangent line intersects the x-axis. They called that a. And so if I find the relationship between a and p, it'll give us basically the exact same relationship between b and q. And then we'll just try and check which of these relations holds. So this is the point p e to the p, and the slope of that line is e to the p. Well, that's not how you spell slope. So the slope of that line is e to the p because it's tangent, so derivative and so on. So the equation of that line is y, let's write it like this, y minus e to the p over x minus p is equal to e to the p. And I want to solve for the value of x that makes y equal to 0. So negative e to the p is equal to e to the p x minus e to the p. So negative 1 is equal to x minus e to the p. So x is equal to e to the p minus 1. Okay. In fact, that will be a is equal to e to the p minus 1. I probably should have substituted a in all these places, but that's fine. This also gives that b is equal to e to the q minus 1. So, what can we say about what can we say about the relationship between these numbers then? Let's suppose p is greater than q for now. Then I have a minus b is equal to e to the p minus e to the q. None of the some of the relations we have do involve an a minus b if you rearrange them. But e to the p minus e to the q, can we say that this is greater than p minus q? No, because if p and q are negative, let me make sure I did this all correctly. We have a tangent. y minus e to the p over x minus p is equal to that slope. We set y equal to 0 and solve for x. Oh, I found a mistake. Of course I did. Of course I did. Why wouldn't I have a mistake in one of my videos? Why wouldn't I? X minus p. So now, subbing in 0 for y, e to the p is equal to e to the p a minus p. So I have -1 is equal to a minus p. So p minus a is equal to 1. And this, of course, means that q minus b is equal to 1. So p minus a is equal to q minus b. And that's option C. All right, well, I'm happy I didn't go further without checking my work and catching that mistake. Simple algebra mistake. I copied this p as e to the p for some reason. So yeah, it comes out pretty straightforward. I mean, I suppose in a question like this, there might be several different ways to manipulate this relation. It just so happens I chose the one which allowed me to identify. I guess there's a lot of different ways you can manipulate it, and there's no guarantee that you come up with one of the answers they're asking for, but it's a pretty basic looking expression, so there's only so much you can do. And when you're trying to solve for a in terms of p, this is, I mean, I've done it here. A is solved for in terms of p here. And when you see that as an intermediate step, this difference is equal to 1. You should be pretty quick to identify that option C is what they're looking for. If I have any more mistakes, I'll let you know. Thanks for watching.